Hello, I am Elizabeth Kelly, Managing Director for the International Commission on the Biological Effects of Electromagnetic Fields. This is part 3 of the workshop that we held at the Royal Society of Medicine in London, England on June 14, 2023. The title of the workshop is Radiofrequency Radiation from Wireless Communication Sources. Are the safety limits valid? The opinions expressed by the speakers do not necessarily represent the positions taken by the International Commission on the Biological Effects of Electromagnetic Fields. Dr. James C. Lin is Professor Emeritus at the University of Illinois, Chicago, where he has served as head of the Bioengineering Department, Director of the Robotics and Automation Laboratory, and Director of Special Projects in Engineering. He held professorships in electrical and computer engineering, bioengineering, physiology and biophysics, and physical and rehabilitation medicine. Dr. Lin is a Life Fellow with the International Institute of Electrical and Electronics Engineers, and he received the bachelor's, master's, and PhD degrees in electrical engineering from the University of Washington in Seattle. He was editor-in-chief for the Journal of Bioelectromagnetics from 2006 to 2022. He is a recipient of the D'Arsonval Medal, the highest award given by the Bioelectromagnetics Society. From 2004 to 2016, Dr. Lin was a member of the International Commission on Non-Ionizing Radiation Protection, ICNIRP, the organization that sets the EMF exposure limits that are used by most countries.
Good morning or good afternoon, as the case may be. I hope you are enjoying your participation in this workshop. As you know, microwave and okay, here it goes. Sorry, there was a slight delay. As you know, microwave and radio frequency radiation are part of the electromagnetic spectrum. They can also be, the electromagnetic spectrum can also be divided into ionizing and non-ionizing domains. Gamma ray and X-rays are in what we call the ionizing radiation domain. The microwaves and radio frequency radiations are in the non-ionizing radiation domain. Like gamma ray and X-rays, microwaves and radio frequency radiation are not visible to human eye. The biological effects or health effects, there is a delay in this process. It's not the health effects of microwave and radio frequency radiation has been, as many of you know, a subject of scientific research for at least 70 years. And safety guidelines has been promulgated for more than 50 years. Therefore, one may get the sense of deja vu because we have been there and done that. So the question is, where is the beef? Are we still, or why are we still discussing exposure limits, guidelines, and standards? Next, please. Maybe the control room can shift it for me, but it's not responding as rapidly as I click my laptop here. In any case, the public health issue is really quite amazing today, because even with the exposure limits that's been promulgated for more than 50 years, the questions of whether there are any health hazards persist. Indeed, the answer to that question is that with high degree of agreement, there is consensus that acute high intensity, high absorption rates can produce adverse thermal effects in tissues. However, the controversy arises from repeated or long-term exposures, or that I mean greater than 6 minutes or 30 minutes as stipulated in the exposure limits that's been published. Of course, a more important issue is the possible delayed health effects at low levels, including the genotoxic effects, which eventually could lead to cancer development as well. So in this talk, I would first like to, next please, start with the brief review of the exposure limits the development process as it had started many years ago. In fact, the first limits was set at 10 milliwatts per square centimeters. Today, we will say it's about 100 watts per meter squared in 1/10 of an hour. This was introduced in 1966 to limit excessive tissue heating. It was recognized by the American National Standards Institute at the time. A minor amendment to that recommendation was introduced in 1982. In that case, the 0.1 hour was replaced by 6 minutes. It's a bit subtle in the sense that while numerically they are essentially the same, conceptually the intent was to introduce a slightly better sense of precision rather than the more qualitative 0.1 hour. A major improvement was inaugurated in 1986, where the concept of specific absorption rates in watts per kilogram was introduced as the basic restriction by the National Council for Radiation Protection in the United States. The specific absorption rate in watts per kilogram is in contrast to the incident power density expressed in terms of milliwatts per square centimeters or watts per meter squared, because one is external exposure, the SAR refers to power deposition or absorbed energy. That particular concept was incorporated in the IEEE standards published in 1992, where after having studied the interaction of electromagnetic fields with biological systems and available data at the time, a number of 1 gram at 1.6 watts per kilogram was suggested as the exposure limits or the basic restriction as in the IGNER case was referred to. But again, this recommendation was recognized by ANSI. In 1996, many of you may recall, in response to the proliferation of wireless mobile telephones, the US Federal Communication Commission implemented a set of rules for permissible exposure based on the NCRP recommended limits of 1.6 watts per kilogram in 1 gram of a tissue. As David had mentioned, IGNER got its starts in 1992, and in 1998, it published a new set of exposure limits which, in contrast to the process that David had mentioned, instead of going down, IGNERB had decided to increase the basic restriction from 1.6 watts per kilogram for any 1 gram of mass of tissue to 2 watts per kilogram in 10 grams of tissue. Of course, as we all know, since a couple years ago, that ICBE has been established, and hopefully the activities that is initiated will lead to some improved approaches to setting exposure limits. Well, let me continue with the exposure limits development. In 2001, the International Committee on Electromagnetic Safety, in short, ICES, was approved by IEEE to replace its C95.1 committee that established or had promoted the then existing exposure standards. In 2005, ICES revised its standards and surprisingly adopted IGNERB's 2 watts per kilogram SAR over 10 gram in preference than their 1.6 watts per kilogram in 1 gram basic restriction. I believe it was done in the name of harmonization. It is also correct to say that the process did not take into consideration the scientific knowledge available at that point. Fast forward, in 2019, ICES updated its standards, and in response to 5G and the use of millimeter wave spectrum, introduced the concept of skin or superficial power density as a basic restriction. In 2019, FCC reaffirmed its rules that was published since 1996 to assure the public that the 1996 exposure limits are equally exposable, equally applicable to 5G operations. And a year after, in 2020, IGNERB revised its guidelines, and with a even more clear emphasis on heating effects associated with the RF exposure. What is also surprising in the process that it minimized any pulsed effects. This table summarizes the current exposure guidelines and standards based on thermal effects for safe human exposure to radiofrequency radiation as published by ICES and IGNERB. The frequency ranges covered goes from 100 kilohertz to 300 kilohertz. The salient feature of the revised standards are the induced temperature elevations. In the case of whole body is set at 1 degree Celsius from throughout the spectrum of interest here. And for the spectrum between 100 kilohertz and 6 gigahertz, the temperature rise of 2 degrees Celsius was chosen. What is more significant, perhaps, in this case is for 5G frequencies above 6 gigahertz to 300 gigahertz, including the millimeter range of 30 gigahertz to 300 gigahertz at an elevated temperature of 5 degrees Celsius was selected as the basic restriction. Of course, all of these applies mostly for short exposures of 6 minutes or 30 minutes. And as Kent mentioned, a safety or reduction factor of 10 in the local exposure case was introduced for the general public, and the reduction factor of 2 was introduced for the working population, or the workers who deal with the related industry. Next, please. I think what is significant to observe is that in these revised exposure guidelines, there are several identifiable anomalies or inconsistencies. I begin with the ignorance deletion of post-exposure limits from its 1998 restrictions. This is contrary to not only the recent concerns on 5G and its pulse modulations, but it is also in contrast to the persistent concern that has been expressed over many years. Of course, as I mentioned, both ICES and IGNER has revised their limits to emphasize, perhaps to better state is to convey their strong conviction for RF heating in interaction of radio frequency radiation with biological systems. As the table suggested, the standards are really based on whole body temperature increase of 1 degree Celsius and local temperature increase of 2 to 5 degrees Celsius. And more significantly, from the human exposure point of view, that these are all pertinent to only short-term exposures of 6 to 30 minutes. Next, please. Aside from the lack of millimeter wave data, the new criteria of 5 degrees Celsius for 5G from 6 gigahertz to 300 gigahertz is very concerning, because as we know, local temperature elevations of 5 degrees Celsius would induce a tissue temperature rise to increase from a nominal 37 degrees C to a hyperthermic 42 degrees C. The significance here is that the hyperthermic tissue temperature of 42 degrees C is actually cytotoxic. It is well known that they can produce exponential cell kills. It is indeed the medical foundation for treatment of malignant tumors in hyperthermia therapy for cancer. At both molecular and physiological levels, there are different working mechanisms responsible for the additive and synergistic interactions of hyperthermia with biological systems. On this graph, basically, it suggests also hyperthermia can serve as a radio sensitizer for ionizing radiation, basically, as well as a chemosensitizer, both in terms of genotoxic effects such as DNA strand breaks, as shown on the upper side of the slide, or from a physiological level, for example, cell proliferation. And these phenomena increases at the low hypothermia level as an additive effect, all the way to a synergistic effect at a higher temperature elevation to about 40 to 42 or 43 degrees Celsius. As already mentioned, in 2011, IARC classified radiofrequency radiation as a possible carcinogen in humans. The classification was based mostly on epidemiological effects that was available then. However, the animal data that is available at that point was only partially supportive. Again, as you have heard, in 1918, the US NTP program reported its $30 million studies over a 12-year period. The observation that radiofrequency radiation can cause malignant tumors in rats, specifically schwannomas, for example, in the heart. In fact, the words of clear evidence was prominently displayed in that report. And this happened at a maximum exposure level of 6 watts per kilogram, which did not cause the body temperature to rise more than 1 degree Celsius following a lifelong or 2-year exposures. The animal data that IARC had thought back in 2011, which they did not have, was provided by the 2018 NTP study. Significantly later on in the same year, as you have heard, the Ramazzani Institute in Bologna, Italy, reported similar observations, although using a slightly different exposure scheme that focuses more on what we refer to as far field or plane wave type exposures, nevertheless involve the whole body. So the NTP and Ramazzani animal cancer reports logically and scientifically supplemented IARC's classification back in 2011. Curiously, the revised safety limits regarded IARC classification as not applicable to the setting of radio frequency exposure limits. Basically, the revision process had objected with putative chance differences from experimental treatments or resulting temperature rises of 1 degree Celsius in rats. It also overlooked what I believe is a serious error, serious scientific error in declaring a 1 degree body temperature rise as cancer causing. At the same time, the decision totally ignored the independent variable for the animal experiment, which is the RF exposure. There are other issues, such as the revised limits do not provide any adjustment for effects due to long-term human exposures for durations greater than 6 minutes or 30 minutes. Moreover, there's a total lack of appreciation of scientific knowledge on chronic toxicology, genotoxicity, as well as the carcinogenicity regarding RF exposures below the basic restrictions promulgated by these exposure limits. One other thing I'd like to point out is that since the 1982, it has relied on a SAR that was set by IEEE ISIS at 1 watt per kilogram, or 1 gram for 1.6 watts per kilogram, or in the case of IGNERV, 2.0 watts per kilogram for 10 gram, and not adjusted whatsoever based on the advances that had been made in many, many years regarding the relationship between the average mass and the exposure duration, which varies also as a function of frequency. I like to use this slides to illustrate the point. Please focus on the blue curves, in particular in this case. What this graph shows is the correlation coefficient between the exposure duration that ranges from, say, 0. For some reason, you cannot see the bottom, or at least I cannot see the bottom on my slide here. From very low to essentially 30 minutes, you can see that the correlation reaches a peak for very short exposures in 1 to 2 minutes, and then start to decrease from over 95% to approximately 85% when the exposure duration is extended to 30 minutes. At the same time, on the right-hand side is a scale expressed in mass per gram. You can see that the correlation actually changes in terms of the size of the average gram from very small to essentially to 10 gram at the 30-minute exposures. Therefore, there is a direct correlation between the exposure duration and the average mass. You really should not stay at either 10 gram or 1 gram when we examine the biological effects of RF exposure for short durations over versus the long-term exposures. But this basically are some examples of the shortcomings the current published exposure guidelines possesses. So as a conclusion, I will say that the mobile phone and wireless technologies have demonstrated without any question benefits to persons in modern society. For impact on health and safety of humans who are unnecessarily subjected to high levels of RF exposure over prolonged durations or even over their entire lifetime, the jury is really already in, regardless whether we wish to accept it or not. As we all know, epidemiological studies and animal investigations are consistent. They are not only consistent, both indicate our exposures as a probable carcinogenic to humans. And from my perspective, I believe the ALARA principle that was first introduced by ICRP or the ionizing radiation community should be and ought to be adopted as a strategy for radio frequency health and safety protection as well. With that, I'd like to thank you for your attention. And for those of you who might be interested in what I have said, here is a list of some related publications from the last couple of years. And of course, I'll be happy to respond to any question you may have or any comments you may have. Thank you.
Professor John Frank was the founding director of the Scottish Collaboration for Public Health Research and Policy from 2008 to 2017. The collaboration, funded by the Medical Research Council and the Scottish Chief Scientist Office, sought to develop and robustly test novel public health policies and programs to equitably improve health status in Scotland. He served as Director of Knowledge Exchange and Research Impact at the University of Edinburgh until retirement in 2021, where he currently is a Professor Fellow and is nominated for Professor Emeritus. Professor Frank is trained in medicine and community medicine at the University of Toronto, in family medicine at McMaster University, and in epidemiology at the London School of Hygiene and Tropical Medicine. He became involved in researching EMF after hearing about plans for deploying the 5th generation wireless infrastructure. Dr. Frank is a special expert member of the International Commission on the Biological Effects of Electromagnetic Fields.
This afternoon, I was asked to summarize some of the key issues arising in this field based on the expert talks you've heard, which I thought covered a lot of ground very well. So I've just created 2 slides, one to summarize what I think the key issues are, 5 of them, 1 line each, and then a few conclusions that I've drawn myself. But I think I first owe everybody a clear statement of any potential conflict of interest. I have never received at any time any funding or equivalent benefits from any commercial entity related to this field, and certainly neither from any legal or other representative of such commercial entities. And although I am now a special advisor to the International Commission on the Biological Effects of Electromagnetic Fields, this only happened in the last few months. And so I'm going to give you a kind of an old GP's, general practitioners and chronic disease epidemiologists summary of these issues as I see them, all but one of which are covered in the paper I published in the peer-reviewed Journal of Community Health and Epidemiology in early 2021. So in the global rollout of 5G systems that's currently underway, this system is proliferating without any significant health and environmental safety research, which has independence from industry. Now, I'm not entirely sure why this is the case, but I detect between the lines of what I've read that there are proprietary issues to the technology, and I'd like to hear the other panelists' view on that. And it may be difficult for independent scientists to obtain the details of MIMO and pulsing and the various beamforming arrays that are now part of many 5G transmission systems, all of which could be expected on basic biological grounds to have somewhat different effects on living organisms. So what we have is a system that's well on its way to global implementation without hardly any evidence about its specific effects, which, as you've heard, we have reason to believe might not be entirely benign. The second issue here is that contrary to some pronouncements on this field, we now have emerging research findings from previous generations, 2G, 3G, 4G, of radio frequency telecoms technology, suggesting that in fact are worrisome biological effects, certainly in the lab. And this takes much longer to establish because epidemiological studies involve, as you've already heard, typically tens of thousands of people followed for many years. But those are increasingly showing convincing evidence of in vivo adverse health effects obtained in living human populations and a few animal and plant populations. So that is not entirely unexpected, because the effects that are most dramatic, like cancers, you've heard about 2 from Erica, are delayed in their onset, as you've heard from other speakers, by decades in some cases. And I'll come back to that point later. So if people began intensive use 25 to 20 years ago of cell phones of the previous generations, you would not expect to see an observable increase in specific cancer incidence in the first decade, or maybe even 2. But more importantly, it would be difficult to show it in routinely collected data, although some investigators have, because brain tumors and acoustic neuromas are often not accurately diagnosed, and it's so hard to get autopsies in the modern world. Issue number 3, there is pretty solid evidence published in peer-reviewed journals, particularly by Leonard Hardell, but others as well, that major global and many national regulatory agencies, as you've heard from Kent, have been captured by vested interests, those in particular big telecom, and that the current safe exposure limits are outdated, inadequate, and fundamentally not in keeping with current scientific knowledge. And this is a situation that I regard as rather unprecedented in recent years, but is extremely familiar to those of you who know the history, as David does, of occupational hazards such as asbestos. So in case you were unaware of it, asbestos was banned in most Western democracies more than 30 years ago. But countries like Canada, which were major global producers, then sought and succeeded to market it with federal government subsidy to poor countries without effective occupational environmental health regulatory capacity, certainly enforcement capacity. And so we exported the toxin around the world. And the reason that's so easy to get away with is because most of the tumors that result, less so the asbestosis, the lung disease that results, but the tumors often require more than 2 decades after exposure begins before they're evident. So that's a very long time for anybody to be able to see a causal relationship. The fourth observation that I think I would make, and it's not been fully discussed this afternoon, but I'd be interested in the views of the rest of the panel, is that the federal agency capture by vested interests has gone much farther in assuring the subverting of local planning processes in deciding about the siting of new transmission masts by at least in Britain and the UK, that is, and in the United States, and I think also in Canada, my homeland. It's basically been able to legislatively preempt local planning processes from even considering health and environmental concerns by alleging that those can only be handled by experts at the federal level. So the only way you can successfully oppose a local mast installation, even if it's at the, as I've recently heard from some citizens who email me about these situations, even if it's on the edge of a preschool playground, the only way you can really get past it, and even these efforts will fail, is by really dutiful communication with local community members, citizens, residents nearby, who then have to sign petitions and have their representation made at the local hearing. But if the mass is already put in place, it's a bit late, is it not? Echoing Ramazzini's observation that an ounce of prevention worth a pound of cure. Now, it might be interesting to know that I've recently been in touch with one of the few people who's had some successes, certainly in Scotland, at stopping masts by this strategy of contacting a lot of local residents. And he pointed out to me that the council, in this case, the city council that is responsible for the local planning process and runs a hearing about any issue that arises that's controversial, only send a notice to about 30 of the nearest households when such a tower or mast is being considered. And but the same number they notify officially when a person is building a new garden shed. That's certainly cause for thought. Marcellus, the guard in Shakespeare's Hamlet, famously said, "Something's rotten in Denmark," in the state of Denmark, actually. But if we substitute Denmark, we substitute the phrase, the current global telecommunications innovation strategy, you don't have to be very imaginative to observe that something isn't quite right. It's also imperative that the public understand how easy it is to delay and even avoid entirely hazard regulation when the evidence is subtle, and especially when the adverse health effects are delayed by years, as with asbestos and its specific tumor mesothelioma. Another observation familiar to those of us who've had anything to do with the tobacco industry over the last, well, getting on to half a century, is that manufacturing doubt through the recruitment of qualified scientists to seed doubt about bodies of evidence that run counter to the interests of these typically multinational corporations is a well-documented technique. Can be quite successful for decades to delay and avoid regulation of hazards. And in the case of tobacco, that was moderately successful until remarkably recently, and still plays a role in parts of the world where there's very little regulation of tobacco. So although I and many other people, including the commission that Kent sat on in New Hampshire, have called for a, quote, moratorium on the current 5G global rollout, unquote, I think that is pie in the sky. And instead of hoping for the impossible, I would simply quote Margaret Mead, a cultural anthropologist. She once said, "Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has." That's it from me, David.
Well, thank you very much, John, for those very erudite and sometimes witty remarks on the state of Denmark, or rather the state of the global telecoms industry and what it's doing to us. I read your paper 4 or 5 years ago on this subject and found it a really fine piece of work, but I've never met you before, and it's been a great pleasure to meet you in this kind of virtual way.
We're going to conclude the workshop with a selection of questions that were asked during the workshop. We had more questions than we possibly could answer. So we're going to post those questions on our website, along with the recordings and the speaker slide presentations.
There's one here that says, I see a problem with antennas in the devices themselves. Their poor technical quality causes users to experience bad coverage. Even telecom experts admit there's some issues. The solution was to increase cell tower output. Is there any knowledge on the panel about whether device antenna design with 5G is improving? Could this allow for lower local body exposures and lowering of cell tower output?
Anybody else want to take it, or should I take it? Have a go at it. Okay. Yes, there is a problem. I don't know if you are aware, and the question seems to relate to 5G, is the way it works is it uses what's called a phased array to have a very directive beam, kind of like a flashlight beam. The larger you make the antenna, the better you make the antenna, the more you're able to steer energy in a very narrow corridor. And so, yes, you can definitely, I'm actually going to be careful here. Whoever posed the question is correct that one of the solutions that the industry has done is they've simply cranked up the power. It's not that hard to do it. And then you get the coverage, but you don't get it in the directive way that is intended. So I think that more work is done, and I think somebody else has mentioned the proprietary nature of the antennas. I'm working with somebody right now trying to figure out what's going on with the 5G facility outside of their place, and it can't get information. You would think that something that's posted out in the public, that is radiating the public, you'd be able to get information about it. But that turns out not to be the case.
Okay, I think, James, do you have something to say on that technical question about antennae?
My sense of the situation is that industry in general are not concerned about human exposures. What they are interested in is how efficient their product can reach the customer, or how could they satisfy the desires of the customers in terms of clearer, better communications, for example, in this case. So let me just use an example. For the GSM cell phones, for example, I believe the allowable output power is between 125 milliwatts to 250 milliwatts. In fact, all they need is maybe about 5 milliwatts, which is sufficient in most cases. But there's no desire to decrease the allowable limits, because if anybody proposes, I think there is going to be an uproar against it. Well, the same thing is true with 5G and millimeter waves. Kent is correct. The unique feature about the 5G millimeter waves is because of the short wavelength and the phased arrays they use. They can basically zero in on a given customer, or at least a given location. So they will be able to satisfy the customer's desires in those cases. When it comes to a MIMO, multiple input, multiple output type of operation, it is really a technological issue whereby you make use of the system as efficiently as you could to reach as many customers as you might be able to do. But in most cases, unfortunately, in this case, you have to locate the base stations or antennas fairly close to your customer. So there comes the rub in terms of, like Kent was saying, in some cases you can ask the industry to locate the base stations 500 meters away from where people might be, but that would run counter to the so-called efficiency of the systems. So that's why you will see these 5G towers in urban settings, literally outside of your apartment or windows, because that is more efficient and more supportive of the communication aspect of the system. So there is a bit of dichotomy how might one to do it. But on the other hand, I would say, as I said earlier, it is counter to industry's interest, and unfortunately, the government, the regulatory agencies are not as insistent as they should be to lower either the output power or the exposure levels.
Okay, thanks, James. Erica, another question maybe.
So this talks about the distance from masts and says, in terms of the 500-meter setback, was it conducted with 5G antennas?
That's a really good question. The answer is yes. That we first, we looked at whether or not we would apply that 500-meter setback to both 5G towers and to macro towers. But in that time, and perhaps now in some locations, there is really no difference. In fact, I looked at a site very recently where the telecom industry, had put a tower, a less than 50-foot tower, right outside somebody's bedroom. And they wanted me to come and take measurements on it. It was a 4G tower, and the reason it was below 50 feet was so that they could get around ordinances. They could claim it was a small cell and get around local ordinances. But they had the same things, the same guts as you were, the same antenna, the same transmit power as a 4G. It was a 4G tower mounted less than 50 feet, so they could call it a small cell and get around local ordinances. So we knew about that when on the commission, and we said, well, we can't exempt 5G small cells because industry is simply going to take advantage of it. So we said that we had to have the 500-meter setback for all new facilities, 4G and 5G.
Okay, Erica.
And now I'll just add a little bit to that, because here in the UK we do have a lot of different types of base stations and antennae, and so personally I'm really keen to see a situation where there's a really proactive measuring at different distances from antennae, and whilst you can make provisions of a certain distance from a certain type of antenna, obviously it doesn't mean that that will cover all of the different types of antenna in use. So we need a really detailed approach to mitigation in that way. Thank you. This question says, how about the damage from transmitters and street lights? Can, in terms of your average street light furniture, can these penetrate walls? This question says.
Well, to no greater degree than a regular macro tower or a 5G tower. The higher you go in frequency, the less penetration through a wall you'll get. So the ones, and some of these new facilities, some of these antennas, the new antennas, they look like street lights. You can't really tell the difference. And they also have transmit antennas that look like legacy electronics or electrical features, power features on power lines. So you see something that looks like an old transformer, you wouldn't think anything about it, but it is in fact a 5G antenna. And that's why I get called sometimes to just come along and make measurements. And I have to use a spectrum analyzer to find out what frequencies a particular radiation is coming from. But it does come from a lot of places, including street lamps. And one of the only ways you can find out is by making measurements. Another advantage of having a meter is finding things in your home that radiate. Turns out it's hard to buy an appliance nowadays that doesn't have an IoT, Internet of Things device, built into it. And I know some people who are electrosensitive, they get a new appliance and they find that, all of a sudden they're having the effects of wireless radiation. And so the only way you can find it out is whether or not you have the device, in the IoT device in an appliance, is to use your meter. And then to turn it off. Sometimes you have a device like a wireless printer. It's really a challenge to turn off that transmitting the transmitter within it. So, and the only way you can find out if you actually have turned it off is by making measurements.
Okay, Erica, a couple more.
A lot of people have posted statements as well as questions, and some of them are brilliant. And there was so much that all of the presenters had to exclude from our talks to keep this in such a short time for you. And one person's pointed out, can we please emphasise that so much of 5G isn't novel, it's existing frequencies, but there'll be a lot more of it. And that is the area that all these talks covered in terms of highlighting damages, biological damages that we are clearly already aware of. And the additional high frequencies where there's a lot less information is just a small part of that 5G infrastructure. So I think that's really important, but just... and somebody's made a comment here that I also think is really important. Can we point out that ICNRP admit that there are issues with body metalwork, particularly implanted devices and things like that? In the medical forum, this is really important. And actually, if you look at the info section in your phone, you'll see that there are cautions there simply about carrying metal coins in your pocket, for example, which can conduct and reflect fields and alter the characteristics of that and the exposures right next to it. And this is important because some mobile phones have been recalled because they have in fact exceeded even the thermal guidance. In fact, 8 out of 10 phones were found in Europe to exceed guidance levels in one of the studies. Let's just look at some of these other questions. We've still got more coming in, and so we will do our best to post some of these on the site. There were a lot more about EHS, and a couple here. A professor has asked, why on earth did they use a phantom head to set guidance which fails to address effects at atomic and molecular levels in terms of real physiological tissue? These phantom head models, as well as being completely the wrong size, in that they were this 90th centile of military recruits, were also filled with a ubiquitous sort of blancmange-like substance, which doesn't reflect a brain and how different areas can absorb to different levels. we've had some pointing out that there have been successful electrosensitivity accommodations. This is absolutely true, and to have some optimism in the debate in terms of moving forward, this is being recognised as a disability in many different countries, and whilst it's difficult to interpret an environmental exposure that's shown to be harmful on so many other levels, to look towards the person as being disabled feels a bit wrong in this instance. But nonetheless, this is a tool that is allowing people to have lower EMF prescribed environments, and there are some changes pointed out here by the Electrosensitive Society to make formal hospital accommodations in Canada in that case, and we're beginning some of those processes potentially over here as well.
Can I just mention a couple of things to fit in there? So in Italy, 2-3 years back, the Appeal Court of Turin awarded occupational health benefit to a worker with an acoustic neuroma here that they said was caused by the work with the mobile phone for about 10 plus years. And in a case like that, which is about compensation, they only have to reach, as it were, a 51% probability that this tumour was caused by that phone. And that was reached. And the court, and do look it up because it's a great judgment, because they dismissed all of the experts put up by the state to not give occupational benefit because they were using ICNIRP's work, ICNIRP science. And the court, those judges said, we've looked at the literature, we've looked at ICNIRP, and we're dismissing ICNIRP's evidence because it's just not reliable, it's biased, and we're going to go for independent scientists. So that judgment was pretty critical. In France, a farmer gets half the compensation for his lost output of milk because his cows were near overhead power lines. Now, they too are a form of non-ionizing radiations. And back in 1979, an astute epidemiologist noticed that if you looked at children born within 400 or 500 meters of overhead power lines, a form of non-ionizing radiations, they got a twofold excess of leukemia. And by the time IARC looks at this in 2002, they conclude that ELF, extra low frequency, from overhead power lines is also a possible carcinogen. And that's also not ionizing radiations. So that's important to know those things. Erica.
A very important question here that talks about some of the very high frequencies proposed. And this points out 26 gigahertz. And it says, given that there'll be antennas every 100 meters to 300 yards, what will be the health consequences of that specific frequency and types of antennas? And that's called densification, when we see this great proliferation in terms of every few yards. And there's a comment here that some governments are saying that it's like 4G, so no problem. I think we've highlighted that 4G is a problem. However, these very high frequencies will have a different set of biological effects that are somewhat unique to them in terms of the biophysics. And I've already pointed out how the wavelength size, when it approximates the size of insects, could be cause a resonance effect and a lot of increased power absorption in those creatures.
Yeah. Just a note there, the Dutch Health Council produced a report in 2020 just on 5G. And whilst it was largely supportive of the government and therefore the telecoms industry position on this precise question of 26 gigahertz, they said, it's quite likely to be problematic. We don't know very much about it, and we call for a moratorium on the 26 gigahertz level, so that you can use that as good evidence from a bunch of people who otherwise were quite, lackadaisical, as it were, about 5G. But on that particular frequency, they were worried. The Dutch Health Council, the Netherlands Health Council, it is.
And
Thanks.
Bringing that back to human health again, what happens when you have those high frequencies is because they don't penetrate very well, that energy is heavily deposited, 80-90% plus, in the skin. And there's been a sort of marginalisation of that issue, and they've said, well, it's only skin. only somebody who isn't a doctor could ever say it's only skin, we don't need to worry about it. It's your largest organ, and it is incredibly important in regulating a lot of secondary systems, as well as the fact that obviously skin cancer is a significant cause of death in younger age groups now. So it's actually extremely important that it affects skin, the eyes, the testes, all of the external structures could be more heavily affected. And there's some very important work by Niels Kuster et al., where they have shown that these, especially a lot of these fields are averaged when they look at safety thresholds, but actually when you look at the peaks that can happen, which are higher with 5G, that can deposit very high energy in that superficial layer, causing, one of their papers suggests that as it's proposed at the moment, it could cause irreversible skin damages.
David, you had mentioned the emissions from microwave ovens. Actually, you are correct, very much so. However, at least in the United States, the Food and Drug Administration's or the Bureau of Radiological Health today is more of a medical radiation and medical device branch, has a federal rule that allows microwave ovens to emit much more than the cell phone. So the justification on that back in the early some 30, 40 years ago was it was considered as a performance standard. Therefore, it was allowed for the microwave oven to emit up to 5 milliwatts per square centimeters or 50 watts per meter squared anywhere from the surface of the microwave oven. So that's a unique situation. Similar kind of situation exists for medical devices. There is also a medical device exemption in that, unlike most other electronic devices, medical devices, in many cases, for example, implanted RF devices are not within the rules and regulations. So therefore, some of them may emit more than the limits would allow. So we need to keep those things in mind. But there are two types of exposure. One is device performance standards as well as exposure standards, which are different, of course.
Yeah. Thank you. That's very good clarification of that point. Erica.
There's a question here. What are the names of organisations in the UK, including parent groups, that promote either reduced RF levels for children or safe tech in schools, including cell tower setbacks, etc.? So there are a number of different organisations that have specialist areas of their own, and some focus on schools. I know Safe Schools Information Technology Alliance is one of the schools-based groups. There's a brilliant website, wifiinschools.org or .co.uk, but with information put together by neuroscientists, so that's great regarding schools. FIRE, the group that I direct, that is Physicians' Health Initiative for Radiation and Environment, firemedical.org. This responds to another question as well. Somebody said, you said doctors get on board. How do they get on board? And this is such an important question, because I am contacted quite regularly by doctors, and some of these doctors have symptoms themselves, and they don't know who to go to. They don't know how to talk about it. They're frightened to share it with their colleagues quite often. But actually, we need open discussion groups where doctors do feel that they're in a comfortable space to discuss the emerging evidence. The only reason they feel like that is because most of them have no idea how much of an evidence base there is for their concerns. And so once they're connected together, that makes a big difference. So I'd really welcome those groups to join FIRE, and you don't have to be a doctor, anyone can join, but we do focus on medical doctors. And IGNIR, is a group here in the UK, International Guidelines on Non-Ionizing Radiation. They haven't set limits or suggested limits themselves. What they've done is use the Europa EM 2016 guideline, which is a really useful document for doctors, but also to look at numerical values for better, not protective, we wouldn't say, but better safety levels. And the ignir.org group have put together practical guidance for how you can meter in your restaurant, your GP surgery, your own home, and try to achieve better compliance with better lower figures, and gives practical advice on exactly how to go about that. This, I think, is a really important point that somebody's made. They've said, we've talked a lot about high frequencies, what about low frequencies? ELF, extremely low frequency, which would be your household wiring, the overhead power cables. There is substantial information demonstrating that to also have biological effect, and that is also currently classified as a group 2B carcinogen. I mentioned that RF is often pulse modulated at ELF frequencies, and some experts would argue it's the ELF modulation that carries some of the biological concern. There are specific studies, though, that show RF to be causing problems in its own right, so we can't say it's purely the ELF part of that modulation, but I'd be really keen to hear Professor Lin's thoughts on that, if
yes.
you want to share any.
James, could you give us a thought on the ELF component of the RF stuff?
Two things, of course, as David York mentioned, I think maybe Erica did that too also. The ELF has been classified as a carcinogenic by IARC. Before the RF indeed, but not much is being talked about these days about it. On the other hand, we talked about the pulse modulation. There are different types of pulse modulations. ELF is one type of modulation. It's just a waveform is different from the digital pulses that is used for communication purposes. So to take a more holistic point of view, in fact, the concern is that modulation could potentially have much greater impact on the biological system than the continuous sine waves is something that more and more being considered, and concerns that have been more often expressed, that especially with the 5G and going on to 6G and so forth like that, pulse modulation are definitely going to be an essential part for its operation. So it makes scientific sense to invest research in those areas, especially when one talks about neurodegenerative diseases and so forth, and the knowledge that pulse operations potentially can have a much greater impact of its interaction with the neurological systems. So it is somewhat surprising that IGNERV has so deliberately deleted from their 1998 guidelines the part that has to do with pulse modulations.
This is more of a statement, but I think incredibly important, and thank you for that, come from the audience here. This is just pointing out a bit more on the ecological effects and talking about the enormous declines that we've seen in so many different types of species, vertebrates and invertebrates. And I know there are a lot of well-demonstrated explanations for some of those, but there is an amount of it that remains unexplained with question marks, and so much of the literature base that you will find here could go a long way to explaining some of that decline. And I would really love to see some of the environmental groups be opened up to this issue properly, because they're extremely unaware.
While you're looking, could I just ask James why IGNERV has ignored the environmental dimensions out there? And there's as you know, James, there's lots and lots of science about it, and they just decide that they were not going to look at the environment. Why was that, do you think, and might they change their mind?
Well, in part, this can be traced to the conviction of nothing but heat. If one takes that point of view, the environment, and if you put it very simply, can deal with heat much more readily than the human body would, or the mammal would. So from that perspective, is not nearly as much interest. But I would say, though, I think from what I have heard, there has been some germ of interest expressed in terms of taking a more holistic point of view rather than just take a more restricted point of view. How far that will go is difficult to say.
Yeah. Related, ionizing radiation for years has distinguished between big people and little people, with lower limits for little people and fetuses and pregnant women and so on. How come ICNIRP has ignored the whole of that field?
Well, I would say that it has not, but there is an inertia in terms of where you put the emphasis. If you have, if I may call a bias toward a certain principles, and then you may take the view that everything looks the same, it doesn't really matter kind of situation. But in terms, I think Erica showed one slide that suggests variances in the energy deposition pattern between a child's head and adult's heads and so forth. That actually scientifically is valid because both the dielectric property of the head as well as the size of the head is such that the radiation can penetrate much more deeply in a child's case compared to an adult's case. So that knowledge is out there for quite some time, and different people has different views of it. And there are some minor details in terms of how deep and so forth like that.
I don't know who this came from, but I do think it's important. It says, this is a statement, not a question. When policymakers set policy and standards, they should take a holistic view of the science. It's not appropriate to handpick poor studies to make a point for industry or campaigners. A consensual view is required by all involved. That's what we seek. Obviously, that's what we seek. And in fact, that's really why we're here today. So we did invite, I wanted to point out that we invited everyone in this country and many other countries in terms of guideline setting groups that we could think of. And we hope some of them are on the call, some might be here. But we do invite that kind of debate. I agree that's exactly what needs to happen. And of course, we focused on the literature that we're concerned about today. That was the whole point of this conference. And of course, there are studies that don't show a concern. But I think we've more than demonstrated why we're focusing on the ones that do.
A quick comment on that. Consensus isn't always the best thing. The top committee in the UK looking at nitrogen dioxide and its contribution to air pollution, they looked at all the literature and they had a majority view of top scientists and a minority view. So we invited them to a workshop about why do scientists honestly differ on the interpretation of the same evidence. And they gave two different positions. And it's about what paradigms you use, what weight you put on toxicology versus epidemiology, etc. So sometimes in controversial fields, you do need to break up the consensus and get the transparency out. Why do they differ? So, yeah. Agreed.
All important points. And so to wrap up, this was a note that was passed to me from somebody in the audience. And it's a statement, historical statement from a 15-year-old girl. It says, why was such an important warning from the EMF scientists appeal not on the 6 o'clock news? Yeah. I can tell you that that girl is unfortunately no longer with us, but she had EHS.
Yeah.
Thank you very much for your time.
Yeah. Okay, and just need to make a couple of thanks to, first of all, the speakers, Kent Chamberlain all the way over from the US, and James Lynn all the way over from the US, and Erica from here, and John Frank up in Edinburgh. Thank you all for some wonderful contributions that I think we've all enjoyed and learned a lot from.